we're going to look at constant velocity problems. This is when the acceleration is 0, and how do we solve these? Okay. So if the acceleration is 0, it's also a constant. So that means if we have a constant acceleration, we're going to list our variables. And so I list mine, x naught, x, v naught, v, a, and t. Now, the unique thing about a constant velocity problem is that the velocity stays the same number, and the acceleration is 0. So here I'm going to write 0 meters per second squared, or whatever units you prefer. And then these two values, I usually put this little symbol to say that they're going to be the same thing. Whatever v naught is, v is going to be. Okay? So let's try a problem. I thought this one was kind of interesting. So recently, they changed the speed limit on the interstate for me. My commute is 22 miles by interstate. It used to be 65 miles an hour on the interstate. I'm a law-abiding citizen, so I drove 65 miles an hour with the cruise control for 22 miles. Now it's 70. So how much time did this save me? So in other words, how long did it take me to go 22 miles at 65? How long did it take me to go at 70? And how much time did that save me by them upping the speed limit on the interstate? So let's figure that out. So the first thing we need to do is identify some information. Well, I have my cruise control on, so my acceleration is 0. This is a constant velocity problem. So if you see acceleration is 0 or constant velocity, you know the other one. So acceleration is 0, I know it's a constant velocity problem. If they tell me constant velocity, I know my acceleration is 0. So this is what my setup's going to start to look like. And so let's add the other information in. So I start at 0 miles, I guess, and I go to 22 miles on the interstate. So I go all 22 miles on the interstate for my speed. So we're going to have to do this twice, once for the slower, once for the faster. I'm going 65 miles per hour. My acceleration is still 0, so it really doesn't matter the units I put on it. I can put miles per hour squared if I wanted. And I'm going to try and find the time. Now, because I'm using miles and miles, I'm okay. Because I'm using miles per hour, my time is going to come out in hours. If I'm using meters per second, I'm going to need to use meters, and my time will come out in seconds. Okay? All right, so what equation should I use? If your acceleration is 0, you're always going to use equation number 2. So equation number 2 is x is equal to x naught plus v naught, v naught t plus 1/2 at squared. The reason we're going to use equation number 2 is equation number 1 for us just tells us the initial and final velocities are the same. We already know that. Equation number 3 for us tells us that v naught squared equals v squared. We already know that too. And our fourth equation, the definition of average velocity, it's not ideal for this situation. You could use it though. So we're always going to use this. The nice thing is the acceleration is 0. So what's 0 times anything? This whole term becomes 0. So this is what our constant velocity problem looks like. So my x naught is also 0. And so now I just need to solve for time. So I'm going to divide my v naught over. So my time is equal to the distance I have to travel divided by v naught. So I can do this for both of them. So for the slow, I'm going to have a time which is 22 miles divided by 65 miles an hour. This is going to give me a pretty small number in hours. So what I'm going to do is I'm going to go ahead and move it into minutes. And so in minutes, that comes out to be 20.3 minutes. So it takes me 20.3 minutes, roughly, assuming I don't have to slow down for anyone. The fast, so when I'm going 70, okay, my new time is going to be the same setup. The only difference is instead of 65, I'm putting 70 in here. The setup's going to be the same. That gives me a time of 18.8 minutes. So when I subtract those two, I find out that I'm 1.5 minutes faster. So my commute has been cut by 1.5 minutes. Now, this is where it gets interesting. That's 1.5 minutes for every trip. But I go to school and home every day. So that means every day I'm saving 3 minutes per day. And if I go for a whole school year, so 180 days for a round number, it saves me 9 hours. So in just changing the speed limit from 65 to 70, I've saved 9 hours of travel time in 1 year. That aside, the big ideas for constant velocity problems, acceleration is 0, velocities are the same. Since acceleration is 0, you're always using equation number 2.